Not too sure what's happening here, but please let me know if you can hear me. Are you guys able to hear me or see my screen?
Yes, I can hear you.
All right. All right. So today we're going to start with an introduction to AI, to Huawei AI platforms. So Nonfundo, can you please remind us again what are the 4 elements of AI if you want to create an AI tool? What do we need? What are the 4 elements?
Computing power, scenarios, algorithm, and I forgot the last one.
You forgot the last one.
Computing power, algorithms.
You say computing power,
algorithms, scenarios.
Yeah.
Or why? I was never ready.
How can you forget the last one? Okay, tell us, you want to create an image classification model to distinguish between oranges and apples. What do you need to do that? What will you need? Okay, so you need the computing power, okay? Any hardware that you're going to use, all right? The second one, you spoke about algorithm. Obviously, you're going to use the CNN, convolutional neural network, to train your model. You spoke about scenario, which we mentioned already. The scenario is the idea that you have, which is the classification problem that you want to do to distinguish between oranges and apples. Okay, so what the 4th one? What is missing there? Now, Fundo, what didn't I mention? What do you think is missing for you to make this project a reality? Samkelo, can you help me? What are the 4 elements, of AI?
It's algorithm, application scenario, data, and computing power.
Yes. So it was data that was missing. So we've spoken about data. We spoke about algorithm, right? Obviously, a scenario is any idea that you have. Okay. Now we're going to talk about computing power. All right. Just kind of a recap thing. All right. When we're trying to create a model, there is only 3 types of problem that we're going to solve. Can anyone remind us again the 3 problems that we are solving in AI? Whenever you create an AI tool, obviously you're solving a problem, but all those problems are classified only in 3 problems. So can anybody remind us what are the 3 problems solved by AI? Anyone? Daily, what do you think is the problem that we're solving with AI? What problems are we solving with AI? Do you have any idea of what problem we are solving with AI? There's only 3 problems that we are solving. Samkelo, what are the 3 problems we're solving with AI?
I think it's clustering, classification, and regression.
Perfect. So those are the 3 problems we're solving with AI. Either we're solving a clustering problem, or a classification problem, or a regression problem. So the classification problem, if we have to, if the outputs that we're going to have with our AI will be a certain category. The clustering problem, if we're going to have data into groups based on the similarity, and the regression problem, if the output of our model will be any value, any discrete value. So basically, those are the 3 problems that we are solving with AI. Okay. All right. And then when we try to train our model, to teach our model to understand, to get an experience over the data and be able to predict future, from the future example, future input that we're going to give the model, and it's going to be able to give us the prediction. So now, in the process of teaching the model, that process is called learning. So it's called machine learning. So the machine is learning. So how many types of machine learning do we have? How many ways we can teach the machine? Yes, Sako Sitole. Sako, yes, tell us.
3. It's
Okay.
3.
Yes, what are the 3 ways of teaching the machine?
It's 3.
Yes, yes. What are the 3 ways?
There is supervised, there is unsupervised, and there is what's this one? The one where they punish the
Reinforcement.
AI. Reinforcement, yes.
Reinforcement learning. Okay, perfect. So those are the 3 ways of actually teaching the machine. And the difference is that the supervised learning, it means we give data that are labeled, so the machine knows what the data represent. Unsupervised, the machine doesn't know. The machine has to discover by itself. And reinforcement is when we create an agent, put it in an environment, and let it learn from itself, and we're punishing it or giving it a reward. So that's reinforcement learning. So those are the 3 ways of teaching the machine how to understand whatever task we give it to the machine. All right. So now, as we're teaching the machine, all right, as we're training the machine. So now, as we're training the machine, we realize that we are having an issue with as the machine is learning, the machine is setting its own parameters, which will be the weight, right? The weight between in the neural network. We have different weight being changed by the machine as the machine is learning. So if we realize that, so to stop the machine from using any value of the weight, which can lead us to a problem called overfitting, right? And overfitting problem means that our machine is trained. We think that the machine is really accurate, But when we bring new data, the machine is struggling to predict with the new data. So we now have an overfitting problem. So can anybody give us any way we can help our machine not have an overfitting problem? How to prevent an overfitting problem? Can anybody tell us, give us any methods, any ways of preventing an overfitting problem?
Early stopping.
Sorry, come again.
Early stopping.
Yes, we can add a normalizer called early stopping. What is early stopping? It means we, instead of training a certain amount of time as we're training, we realize that as we were training, the loss became smaller. But as we continue training, the loss starts increasing. So we can just look at the moment where the loss was really smaller, and then we can stop our training at that moment. So we can do an early stopping, which is a normalizer. What other example of normalizer can we introduce? Anybody else?
A dropout.
Yes, a dropout. That means that we will drop out a certain group of a certain part of the neural network while we're training our model. So that is one of the ways of doing that. So basically, let's say, for example, you were using two hidden layers, and the two hidden layers, each layer had maybe 16 nodes, but now you realize that no, if you're doing it with 8 nodes only, it's performing better. So you're gonna drop out the rest of the network. Okay, so okay, now we've solved the overfitting problem and everything. So now we realize that okay, it's fine. As let's say we are dealing with we are dealing with a problem where we have to create a classification. We have a classification problem that we're solving, and we have to create a multi-class output, which means that our, let's say we want to detect a picture of a fruit, and we want to see if this is a mango, apple, orange, or banana, right? But now we have to create a certain type of probabilities so that if the probability is between a certain amount, so now we have a probability of the fruit being a banana or being a mango or anything. But now, which means that every calculation in our neural network needs to be converted into a value between 0 and 1, which represent the probability. So now in my neural network, how do I make sure that every calculation will give me a value between 0 and 1 so that I can detect what type of output it is? What do I introduce in my neural network? What part of my neural network will do the job of taking any value, turning it into a value of 0 or between 0 and 1? How do I call that? Anyone?
Is it the activation function?
Yes, perfect. You use an activation function. So an activation function is the one that will help you take the value and convert it into one of the values. So now that I've mentioned the issue that I have, it's to detect a fruit and put the probability there. So what activation function do you think I'm going to use there? So in my case, what activation function am I going to use?
Sir, can you please repeat the question?
Yes, in the case of when we're trying to detect a picture of a fruit and we try to classify the fruits to see if it's a mango, an apple, or banana, so we have about 4 classes there. So now our activation function needs to turn that value into a certain probabilities to show if it's a mango or banana or anything like that. So which activation function specifically am I going to use for this scenario?
What about softmax?
Perfect. It's a softmax function. So I'm going to use a softmax function because the softmax function is specialized for multi-class classification problems. All right. So, so you have an idea on how you are creating the whole AI system, right? So now we can use platforms such as all the AI framework that we spoke about. We can use PyTorch, we can use TensorFlow, or you can use MindSpo, depending on what you want to use. And we spoke about MindSpo, we spoke about this different part of MindSpo in order for you to build this model. So now, what does it mean when I say, if I tell you, if you give me a set of data, a data set, and then I call it dirty data, what does it mean when we talk about dirty data?
So I think it means that the data is not really clear.
What do you mean? What is dirty data?
I think it's data that cannot be used to train a model, or a data that cannot give us a clear output.
Why? Why would the data not give us, not train the data or give us a clear output?
Because I think it's because of the missing values or inconsistencies.
Perfect. So any data that have inconsistencies or any issue is called dirty data. So dirty data are any data that have inconsistencies. So they can have missing values, or they can have the wrong value in the wrong table, things like that. And I promise you, this question will be in your exam, way as simple as dirty data. And you'll be surprised that the answers will be a bit tricky. So guys, I think you must, for those who wrote the big data exam, whatever happened, forget about it. You move forward and do not repeat the same mistake as big data. A lot of people thought it was going to be an easy exam. They could just memorize. But the most important thing is when you understand the concept, it's very easy for you to pass these exams. Okay. All right. So, just to tell you a very short story. With the Huawei program, as an instructor, every 3 years, it's not like in the South African system where people have been teaching a certain course for years and they keep teaching. With the Huawei program, every instructor for every course that they are teaching, every 3 years, they have to write an exam, an instructor exam. And if they fail the exam, they cannot be allowed to teach anymore. So I was in one of the Huawei Awards event, and there was one of the instructors who asked me how I was able to pass the AI exam. So I've never failed any of these exams, and every 3 years I have to redo the exam again, and they update everything they update. I have to do it again, and all I can tell you is the secret to pass this exam is understanding. It's not memorizing. So if you understand what you're dealing with, that's why we say when you're attending class, ask as many questions as you can and you understand. Because if you understand, every time you see a question, it's very easy. Even if you did not memorize it, but it's very easy for you to see what are the wrong answers there because you already understand what we're talking about. So I would really encourage everyone to really participate. You are here to learn. So there's no such a thing as a wrong question. You ask anything, so your question can benefit someone else. but at the end of the day, you get to a point where you have a full understanding of the whole course, and it becomes easy even when you're preparing for your exams. All right. So now we've spoken about that. So now we spoke about different algorithm that you use. So the algorithm that you choose will depend on the scenario that you have. It will depend on the problem that you are solving. So basically, you start from knowing what's the scenario, what problem are you solving, then you see which algorithm you're going to use. So you know which algorithm we're going to use, and obviously you're going to choose if you have a platform that you want to use in order for things to be very easy for you. That's fine. All right. So now you need to understand one thing now. Despite the fact that you have the right algorithm, you have the right scenario, you have the right data, you know, all your everything is fine. It will be very important for you to have the right devices as well, the right computing power. This is why we're going to talk about different computing power that are used in order for you to train the model. Remember, you need devices to train the model, and you need devices to use the model. It doesn't matter if your devices were trained properly, but you're using it on the wrong device. Remember, how do we call it in AI? How do we call, what term do we use it? Model. Remember, we have model training, which means we are still teaching the model how to understand the data. Now, when we are using the model, how do we call it? Model what? Anyone? What's the term that we use to say that we are using the model? Anyone remember?
I think it's called reference.
Yes, model inference. So when we talk about model inference, it means we are using the model. All right. So there will be devices that will be used during model training, and other devices will be used during model inferences. And so basically all these computing powers, all these devices, all these chips that you can have on your device, it's basically the chips that you have on your devices. So those hardware, mostly we'll refer to them as AI processors. Okay, so these AI processors are going to help us with model training or model inference. So in this chapter, we're going to describe all the Huawei development platform in the AI field, including the Ascent computing platform. Okay, so this Ascent computing platform, where we're going to have all these AI chips, is based on an architecture called the Da Vinci architecture. We're going to talk about it. What is the Da Vinci architecture? What are the features of this architecture, right? So, and then a services that is offered by Huawei, which is called the Huawei Cloud AI. The Huawei Cloud AI is a platform or a cloud service that will help you train your model or use your model. So remember what we say with Mindspo, AI all scenario framework. It means that you can train your model from the cloud using certain data from the cloud and using the GPUs that you get access from the cloud. So this service from AI, from Huawei, gives you access to the cloud services that you're going to need to use. All right. So that's what we're going to do in this part of the course, right? So now, when we talk about AI processors, it means all those devices that are going to be used in order for us to train our model. So basically, an AI processor or artificial intelligence processor can be referred as any hardware chip which is designed to accelerate all the AI works that we have, such as machine learning, deep learning, and neural network computations. Because remember, in the neural networks, there is so many calculations happening. Remember, in one of the classes, we saw a video of how the neural network will take every input, assign a bias, assign a weight, and do all the calculations. So all those math calculations happening there will need to use an hardware. So the hardware chip that is used is called an AI processor. All right. So AI processors are actually optimized to handle the massive numbers of calculations that are required for all the AI tasks, right? So you need to understand behind the AI task, we have what we call matrix operations. So matrix operations are high-level mathematical operations that are happening. We have what we call parallel computation. What is parallel computation? It means we have many tasks happening at the same time. So when we look at these issues now, we need a processor for that. And these AI processors are what we're going to use in order for us to do all these tasks. Okay, so you need to understand that we have large computing tasks that are happening in AI applications. So all these AI processors will be considered to be AI accelerators. Okay, because of the numbers of tasks that they do. So you need to understand when we're dealing with Internet of Things, we're dealing with robotics, so sensors, so there's a lot of mathematical calculations happening. Okay, so in terms of the characteristic that we need to have, remember we have what we call a high parallelism, which means that we are executing many operations at the same time when we're dealing with neural network. Okay, we have metric calculations that are happening, and you need to understand that all these operations will really need a high precision. So that's why we're going to need all these AI processors. So now these AI processors we will have many types of AI processors. So we have AI processors that are using during training and processors that are using during inference. Okay, so it's very important to know that because we have so many processors. Remember, in the processors, we can consider, can anybody tell us any processor that they know? Any processor that you know?
Intel.
Sorry?
The Intel Corsa.
What is that?
It's a processor that has many processors inside it.
Yeah, explain yourself.
Come again, sir?
No, I'm saying explain yourself. What do you know about Intel processor?
I know it has many generations. So for one,
you hear yes, there's many generations of Intel, but what is an Intel processor?
Does it not break down? So it's like whatever it has to do, and then it breaks it down into the processes that it has within its.
Yeah, so all right. Is there anyone in class who does not know what is an Intel processor, who has never heard about Intel processor? Is there anyone who needs an explanation on that, who has never heard or seen anyway the Intel processor that we're talking about now? Anyone? All right, so basically, whenever you buy a Windows computer, usually you will see there it's written maybe Intel Core i3, i5, i7, right? I'm sure you've seen that on your computer, or if you actually in this class, you are currently on a computer, maybe you are looking at it on your laptop, it's written there Core i5, i7, or i something like that. Right, so the Intel processor is one of the processors, but it's not really a type of processor, but it is just it's one of the CPUs, right? So the type of processor in this case is a CPU, the computing power unit. So an Intel, so when we talk about an Intel core is just a chip which is part of a CPU, right? It can be considered as the just general purpose processor because that's hacked in ways that applications are working on your computer. So it sees how fast you open your Google Chrome, you open your whatever application you open on your computer, and it deals with that. So you have so basically an Intel processor is just a type of CPU. So when they tell you about a Core i3, i5, i whatever, those are just type of Intel processors, right? You have, for example, your i3. i3 is just a simple processor there, right? Doing a few tasks. But when you have your i5, which is more advanced, right? And then you have your i7. i7 is more advanced in terms of it works better when you have softwares that deal with editing videos, gaming and all those things. And then you go up to i9, right? So i9 will actually have all the heavy load, all the workload that you can have on your computer, right? So you need to understand we have common AI processors on our computers. And on the processors, you have the CPU, which is the computing power unit. And the CPU, you can have some chips like the Intel Core. That's where they tell you Intel Core I, whatever. And then you have the GPU, which is the graphical processing unit, right? So you have the CPU, you have the GPU, graphical processing unit. So basically, the GPU, the advantage with GPU is that GPU works better with advanced parallel tasks. That means you have so many tasks at the same time and everything that has to do with graphics. An example of a chip that is a GPU, you have, for example, the NVIDIA RTX, right? So you have the NVIDIA RTX. That is an example of a GPU. You have the AMD, and then after this, and then you also have the NPUs. Can anybody tell us what is NPU? What does NPU stand for? What is an NPU?
N or L?
Sorry?
Is it N or L? Did you say N or L?
N, like here, NPU. This is a processor.
Is it not?
What does it stand?
I think neural.
Yeah, that is the neural processing unit. So neural processing unit is a chip that works with neural network processors. So an example of an NPU can be the Ascent 310. So the Ascent 310, Ascent 910, those are chips that are used that are represented as NPUs. So this chip, when you buy an Ascent 310 or you buy an Ascent 910 or an Apple Neural Engine, so those are chips that are considered to be NPUs. So understand, on whatever computer or whatever device you are using, you need to understand what type of chips that you have, depending on the problem that you have. So if you're dealing with neural network, you're dealing with an AI, you need to make sure that device has an NPU. Because a device without an NPU cannot do AI processes. All right. So you have an NPU, you have also your GPU would say that, you have your FPGAs. So your FPGA will actually be it's one of the AI hardware that can be reconfigured, so we can actually change it and modify it, right? So there is many of these AI type of processors, but they will all depend on what you're trying to do. Some AI processors works better in inference. Some work better in training only. So how do you understand it? So imagine you are running a deep learning model, right, for image recognition. So if that process is done by the CPU, it may take maybe 5 seconds to recognize the image. But if the process is using the GPU, that can use maybe 0.5 seconds, right? So that's how fast it is. But if it's used by a specific processor, which is specialized for neural network, such as an NPU, neural processing unit, or the TPU, which is tensor processing unit. So these are specialized chips that are created just for AI. So when you look at this, that process, the same process of identifying a picture, will maybe be done in 0.1 second. But if you use the CPU, the CPU can take maybe 5 seconds to do the same task. And the GPU will use 0.5 seconds. So you can see how these chips can do the same task, but in different speed and depending on the scenario that you have. Okay, so so you must understand when you have your phone, for example, let's say you have an iPhone, your face recognition system and your voice assistant, whenever you say, hey, Siri, do this and this and this, you must understand there is a chip being used. So there's an NPU being used. For example, on your iPhone, you have the Apple A series chips, which has a neural engine on it. Okay, so, and then you have other processors that are used in self-driving cars for it to be able in real time to detect objects and take a quick decision. So now, think of it now, when you are talking about the CPU, which has a delay in action. Now, imagine you driving a self-driving car and it takes decisions later. Can you see the danger in that? So that's why we need to use the right processors. So you need to understand that the processors will depend on the type of scenarios that we have. And remember, we have processors that will be used in training. Some of them are used in training and in inference. Some of them will only be used for training. Some of them will only use for inference. Okay, so that is very important because as you created your AI, now you train your model. Now the model has to be used to make predictions on new data. So you will need to quickly. So once the data arrive, you will need to quickly predict what's the output. So that means that you will need processors that deliver faster without using too much energy or without wasting time. So those are the advantages. So basically we have processors for model training and we have processors for inference. So the processors for training will be used especially in data centers. Most of them will require high power, right? And then you have the processors for inference, which will be used on your devices, like on your phone, your cameras, because now it's in inference. Okay, so those are the different type of processors. So you have, for example, when you're training, you have one of the biggest and very expensive processor, which is called the Atlas 900 clusters. So this Atlas 900 cluster is a very powerful processor that is mostly used in what you call that in AI training, right? So any question on this? Any question? Any question? Any misunderstanding? Is there anyone who needs to ask anything? So you need to understand that the Atlas, the Atlas 900 is considered to be one of the fastest computing power that that really exists. You know, it's one of the AI processor that is very that is used especially for AI training. So you can train so many data and advanced AIs. You know, so you have all these things. You know, that's why last time we were talking about this company Nvidia. Which is making so much money because now all these big companies, you have OpenAI, all these companies to train ChatGPT, to train all these AI, DeepSeek, Gemini, Grok, whatever AI you have, you need these clusters, you need these processors, and these processors are very expensive, right? So those are some of the examples of how the processors may be used. So, and then in inference, we also have some processors that are used. We mentioned the GPUs, NPUs, and CPUs. Okay. All right. So I think that will be all for today. So I just wanted to show you. Maybe let me just share this. I want to show you a picture of how the Atlas 900 look like, which help you train the model, like those high level models. When you look at a company such as OpenAI, when you look at an AI such as ChatGPT and what's the other one? Gemini, DeepSeek. I want you to see how they are trained. If you have to use the Atlas 900, I'm not sure. I can't see the screen anymore. Can you guys hear me? Can you guys still hear me?
Yes, and we can hear you.
See, I don't know why the screen is frozen. It's not allowing me to share. Okay, so okay, it's fine. No problem. Don't worry about it. We will. Let me see. Where is it? Where is it frozen? I was trying to show you, but okay, as it's still loading there, I was trying to show you a picture of the Atlas 900. So you see how big it is, you know. It's such a big machine that can, that is used by big companies. So when you're looking at all these processors, they are different, right? Depending on what they are actually doing. But tomorrow we're gonna start from this. Okay, we're gonna continue with computing power. All right, guys. That's fine. Is there any question before we can call it a day?
I have a general question, not something that has to do with today's task.
All right.
It's about input weights. Where do they get them from? That is when they're not using transfer learning to build a model. Like if you were to build your own CNN from scratch.
If you want to build, okay, it's about what? I didn't get you. You say if you want to
Input.
go.
Input weight.
Oh, you mean the input weight?
Yes, the input weight. Where do they come
Okay.
from?
Okay. You need to remember something. The weight. Remember, the weight is a parameter. Remember, the fact that the weight is a parameter, it means that it's a setting that is set by the model, right? So basically, now when you talk about the input weight, it's basically the weights that will be assigned for each input. Can you hear me? Because I can't confirm that this screen is frozen. Can you hear me?
Yes, so we can hear you.
Okay, perfect. So now, remember that now the input weight means that it's going to be the weight that will be assigned to the input features. That means on the input layer, you have the input features that will receive a certain weight. So they will receive a certain value that will show how important is that part or how important is that feature, right? In terms of the model prediction. Okay, so the input weight will just be there to help the model learn from those features. So the input weights do not come from the developer; they come from the model. This is why we have the normalizers, we have the L1 and L2. So we create a restraint where we say the model must choose any value below 10. So it's gonna start from maybe it put a value of 1, 1, 1, 1, 1, 1, and see how it's performing, and then it changed. So those weights will not be just one value. They will keep changing as the model is learning. So the model will be changing those values. So during the training, the model will be adjusting all the input weight in order to minimize the error or the loss. You understand? So you need to understand the input weights are not values that are fixed. No, it's values that can be any value in order for the model to learn from it. So the model is going to be changing these values. And
Seyiskhona batho.
Share sort. Okay, guys, we can turn on the camera.
Let's just wait for a few minutes. It might come back.
so, sorry, I don't know what's happened. I'm not sure. Did you hear what I was talking about? Or was I? Or you couldn't hear me?
We heard you, then you were cut off.
Yes. So basically what I was saying, remember the weight is a parameter, so it's set by the model. The model learns from itself and creates this weight and change them as it learns. So the input weights are not fixed value. There are values that changing as the model is learning. So to answer to your question where you're asking where do they come from, the input weights do not come from anywhere. The model itself sets them. So the model can start, maybe it's give them values of maybe 0.5, 0.5, whatever value, maybe from 0 to 10. That is a restriction that you can create, which is the normalizer. So you can create a restriction there, and the model will be changing these values as it's learning. So those are parameters. So they do not come from you; they come from the model itself. Did I answer to your question?
Not entirely, but I see what you're trying to say.
Okay. Is it clear, or you want any clarification?
I think I'll try and get the clarification on my own, because the question I was asking, I think it's for the beginning of all models, like the first ever models. How do they come up with the thing of weight, assigning weight? I understand that right now, if we were to train a model, we'd use
Yes, that's what I'm saying. That's what I'm saying. You do not set the weight. It's a parameter, which means it's set by the model itself, not by you. You create your neural network, the model is going to be changing the weight. Because remember, you've learned a method called the gradient descent. So the gradient descent you will choose. All you will tell the model is to use a stochastic gradient descent, a batch gradient descent, or a mini batch gradient descent. So if you choose, let's say you choose the stochastic gradient descent, it means that it needs to change the weight of one sample at a time. So it's going to be assigning different values for the first time, change it the second time. So if you say batch gradient descent, so whenever it changes a value for the first input, it's going to change for everything. You see, so now using the gradient descent, it keeps changing the values until it gets to the right value that will give you the less cost, which is the less error. And that will be your model. So you need to understand the weights are those settings that the model are changing in order to make the loss a smaller value. Because remember, in all the loss functions, the weight is one of the is the main variables there. So the more we're changing the weight, the more we're reducing the loss. All right. So was that clear?
Yes, it was. Thank you.
Yes. So all right, guys. Any other question? All right. If there's no other question, I think I will see you tomorrow. For those who can turn on the camera so we can take